Welcome back to Vaathiyaar. In this video, I will be teaching you the differences between the mean and the median. So without further ado, let's get into the lecture. Okay, so what are the differences between the mean and the median? They're both important statistical measures. They're both measures of central tendency. They both provide a summary measure of the data that you are trying to analyze. They both always give us one answer after you're done figuring it out, unlike the mode, which can sometimes give you no answer, no mode, one mode, or sometimes even more than one answer as well. You can have data sets with no mode, one mode, or even more than one mode as well. But two differences that I can think of right now are that the mean helps you figure out the average of your data set, and the median helps you figure out the middle value of your data set. And there are different steps involved for calculating the mean, and there are different steps to calculate the median as well. But there are certain types of scenarios or certain types of data sets where the median will provide with a more accurate picture of the data that you are trying to analyze compared to the mean. And what are those types of scenarios, situations, or data sets? That is what we'll be taking a look at in this video. So without further ado, let's get into the video. Okay, so on the whiteboard, I have written mean versus median. And we are going to use this example to show you why the median can sometimes be or sometimes provide a more realistic picture of the data that we are trying to analyze and look at. So let us first figure out the mean and median for the set of values or for the list of values that I have written here. So we have three numbers. Let's just assume that these three numbers represent the grades for a classroom with just 3 students. I'm just using 3 students now because I want to make this example as simple as possible for all of you to understand. So while looking at this list we have here, we realize that only one student has performed exceptionally well in this class, while 2 students did not do too well and barely passed the course. So the mean equals sum over count. Okay, so this is the formula for the mean. Sum over count. So first we're going to find the sum for these 3 numbers and then divide them by the number of values that are in this list. So what are the number of values that are in this list? The count is 3 and the sum is 4 plus 5 plus 81. 5 plus 4, 9. 9 plus 81, 90. So 90 divided by 3 will give you, you can plug it into your calculators and figure it out as well. But I know that it is 30. So the mean is 30. So the median, we have to list our values in ascending order. It's already listed in ascending order. The second step is figure out if we have an odd amount of values or an even amount of values. So we have an odd amount of values, which is 3. So now the third step is much easier. Since we have an odd set, we just have to count till we reach the count from both ends till we get to the middle. So the middle seems to be 5. Let's take a look. Let's do our steps to check if this number that we have circled here is the median. Do we have an equal amount of numbers on the left and the right? Yes. So there's one value that is greater than 5, and there's one value that is lower than 5 or lesser than 5 in value. Therefore, 5 is the median. Now take a look at the 2 statistical measures that we have figured out here. The mean for these three numbers here, or for this data set, is 30, and the median is 5. You probably would have already realized that these two numbers are different by a large amount. And the median, or let's look at the mean first. Does this represent accurately the data that you have in your hands? Let's just say that you don't have the individual grades of the 3 students in your classroom. You look at the number 30. What conclusions, or what might you think while analyzing it, or while taking a look at it? So you know that the mean is 30. So if you sort of reverse the formula for the mean, you know that your mean is 30, and you know you have 3 students in your class. So your sum, you somehow figure out it's 90. So the sum that we found here, you know that is 90. If you just reverse the formula and figure out what the sum is before you figured out the mean, you realize that, or you will know that your sum is 90. So you will assume that you can make various guesses and conclusions from it. You'll think that, okay, one student got 30, one student got maybe 15, and another student got 45. You could think like that. You could say, okay, one student maybe got 20, 30, 40. One student got 60, 15, and you can make guesses like these forever. But we will not immediately know that this is what we are looking at. We'll make various guesses, but we will probably least expect or least think that only one student in your classroom has done exceptionally well, that has achieved a mark that is greater than 80, and that 2 students barely passed the 10% mark. We won't get to that conclusion immediately. And when you look at the mean, you'll be misled by it. You will think, or your values will seem greater than what is actually there. You'll have a different picture of the data that you are trying to analyze. And let's take a look at the mean, or the median, I should say. The median gives you 5. Okay, so you know that the median is the middle number. You have 3 numbers. Okay, so there's one student who has achieved a mark below 5%. There's one student that's achieved a mark of 5%. And there's a student that has achieved a mark that is greater than 5%. Oh no. So they will see how I got scared when looking at that result. I did not become that scared when I looked at the 30. Well, 30% is still a mark that you need to take a deep look into. But when you look at the 5 year, you will have a better understanding, and the median value here gives you a more real picture, or an accurate representation of the data set. See, let's just say I do not know of the individual values, and I'm only given the median. Okay, we have a problem here. There's 2 students that have achieved below 10%, and there's one student that has achieved a mark greater than 5%. We don't know it's 81, but we know that we have a problem. And you know that most of your students did really bad in this course. And people using this information can make better decisions with it. So you may decide to change how the course is set up. You might ask the instructor what happened or why the marks were this low. You'll sort of have a better understanding of the data that you are analyzing from looking at the median instead of the mean. Now, 30%, they're both marks that are below 50%, and they are marks that you have to take a deep look at and try to fix or try to increase. That's a different story. But what I'm trying to show you here is that with the mean, the values may seem larger than what is actually there, or what you actually have, because if you take a look here, you have 3 numbers. Let me erase this. But if you take a look here, 4, 5, 81. Now, if you look at the number 81, you will think, or you know, that 81 is a number that is larger compared to the other two numbers in your data set. And what do we call these numbers? We call them outliers. Now, what are outliers? They are numbers or values or points that are either or that do not fall in the range of your other numbers, values, or points. And they are numbers that are either too high or unusually large or unusually small compared to the other numbers in your data set. For example, here look, 4, 5, 81. 81 is an unusually large number compared to 4 and 5. Another example of an outlier would be 1, 2, 3, 61. See, 61 is not a number that falls in the range of the other three numbers you have. And it is a number that is unusually or that is extremely large compared to the other numbers you have. So that is what an outlier is. And the presence of outliers like these will greatly affect the mean, because when you are calculating the mean, you are looking at all the numbers. You are incorporating or you are including all the numbers in your calculation. But for the median, you're just looking at the middle value. For if you have an even amount of values, you're looking at the middle two values. But if you have outliers, outliers won't come in the middle. They won't affect your final answer. Your outlier will either come here or will either come here if it's unusually small, right? And you will get a more accurate representation, or you will get the real picture of what's going on by looking at the median instead of the mean when you have the presence of such outliers. Like, take an example. Let us say that we do not have an 81 at all. Let's just say that we only have two students. They both got 4 and 5. Let us calculate the mean and median now. So what is the mean? 4 plus 5, 9 divided by 2, 4.5. So the mean is now 4.5. Okay. And here the median is now 4, 5. If you list them in ascending order, find the middle. Okay, so since we have two numbers, we have to use the rank formula. So that is basically n plus 1 divided by 2, n plus 1 divided by 2. We have two values. 3 divided by 2 is the 1.5. So the rank, or where the median is placed in this list, is in between the first number and the second number. We only have two numbers, so we are going to add these two numbers and divide them by 2. And if you think about it, you are doing the same thing as what you did for the mean. Now you have the same answer as your mean. 9 divided by 2 is 4.5. The mean and the median are both the same here. Therefore, there's no need to check for outliers. You know that mostly they're the same. The mean and the median are the same. And if you take a look at the previous example, the mean is 30 and the median is 5. So when the median and the mean differ by a large extent, you know that there is an outlier, or an outlier is present, and you have to take a look at the median. How do we find outliers? Well, if you have access to the individual numbers or all the numbers that exist in your data set, you can list them in order like this and see if all the numbers fall in the same range, or if there are numbers that are unusually large or small compared to the other numbers. That is one way. You can use a number line. You can plot all your numbers on the number line and see if there are any numbers that exist far to the right, to the greater side, or far to the left on the smaller side compared to the values in the middle. And this is how we can find outliers. You can also graph your points, but that is something that we learn in advanced mathematics. I do not want to confuse you here, because this is a video meant for beginners or someone who's just entering into the world of statistics. Thank you very much. Math Vaathiyaar. We'll see each other in the next video. Thank you.